One of the things we need to figure out is some point, we'll either finish early today. If we do, then hopefully we can grade some of you folks that didn't get a chance to get graded during office hours. So it's kind of rough today, folks coming with questions and then grading and sort of bouncing back and forth. But don't worry, you're not going to lose points if I didn't get to grade you during office hours. So I'm guessing Ken already mentioned there was no extension. So let's see. Today, the assignment's due. For the most part, like the folks that showed me stuff, they knew what they were doing. It pretty much averaged from 6 to 20 hours for folks in terms of the length of time to implement this stuff. So I guess it just depends on how well you know some of the stuff already or how quickly you picked it up. But assignment 3 is going to either go up tonight or Wednesday, and assignment 3 will sort of depend on a bit on what we cover right now in class today. We're going to do something with views, and I wanted to make something where you draw things and something more visual. One of the ones I'm throwing around is so we're familiar, hopefully most of us are familiar with the iPhone and like the keypad or just any keypad on a phone. I'm thinking it might be fun to do like a rotary style one for the iPhone. So like touch, drag, let go, and have it, I don't know. I don't know if I'll be able to cover everything we need to do that today, so if not, I'll come up with something else, so we'll see. Any questions? There were some folks that had UI navigation controller questions and other things during office hours that... Chris?
Are you going to go over any more core data, or are we pretty much done? Because the guy on Friday was pretty fast.
Yes, Colin is really fast. So maybe I'll talk a little bit about core data, just to say a little bit about it today. And probably when I talk about persistence in general, we might look at it again, kind of a little slower. Basically, so core data was, so we have interface builder to take care of our views. Core data is sort of a set of tools and functionality sort of, to help us take care of our models in a nice way. So definitely we'll look at it again at some point in the very near future.
I don't know if we have time for it, but I was hoping we could have an example of coding a purely coded user interface, even if it's just like on this screen.
Okay. So for those in the back that didn't hear, Blake is saying it'd be nice to sort of see the other side of how to do things. So we've, in terms of, say, like interface builder stuff. So we've been doing a lot of things through interface builder, connecting things, creating controllers in there, and setting various properties for them, and then trying to do very little code to hook things up. So at some point, what we're going to do is look at how do we do this stuff without using interface builder, and we'll get to that at some point again, hopefully in the very near future. In another week, I think you're going to be starting on your final project. So, that already leaves, that's 4 weeks, and that's going to be at least 8 lectures that I'll be doing. And there's a bunch of stuff that I'm not going to be able to cover that you're going to have to kind of learn on your own. And that's just sort of the nature of, there's just so many libraries and things. And you got a bit of taste of that, or a taste of that with this assignment where, I said nothing about the NSXML parser besides saying it's a streaming parser. So go to town on the documentation and whatever you can find and implement stuff. And there's going to be a lot of that for the final project. That's just, again, just kind of the nature of this course and how we're doing things. And you'll be fine. You'll be fine. Don't worry. So, okay, more questions? Okay. Going once, twice. Okay. So today we are going to talk about views, and we're going to look through some Apple sample code and discuss custom views and drawing. So how do we, make our own views and display them and do stuff. And today there'll actually be this might make you happy, Blake, but more of what will go on today will be exactly what you're asking for in terms of coding versus like connecting a bunch of stuff through Interface Builder. So, so the future is now, Blake. Right. Okay, so view basics. Let me take a step back and say, we've looked at the model view controller pattern, and this last assignment in particular, we started playing around with controllers much more, and also dealing with models. Maybe you had some sort of article model, and that model had various things associated with it, some sort of feed URL, and a title and a description and various other things you had associated with your RSS feed article. So we have the controller, we have the model, and today we're going to look more closely at the views, so the stuff that we actually see on screen. So some of this we already know just because of the fact that we've had to use them without really looking in depth at them. But so views, what are they? Right? They're the things that we see and interact with. They draw their own content, so there's some sort of visual thing going on. Views are set up in this sort of hierarchical structure where a view can have children or subviews, and the fact that we can actually interact with them means that somehow these views receive events and know that we've poked at them and slid across them or do something or have done something to them. So the views that we've been dealing with are from UIKit. So that's sort of the library, part of Cocoa Touch that deals with views. And so the views inside UIKit, you can characterize them based on this list here. So some of the views are containers, some of them are controls like buttons and sliders, some of them are simply for display, so labels and image views. Other ones are for text, so our UI text view, our UI text field. We haven't really dealt with UI text views, but the text field takes care of one line of input. The text view, this other view, you can have, you could write your own little editor, I guess, if you wanted using this thing. And we've dealt quite a bit with the UI web view. We also have alerts and action sheets. We haven't really played around much with them. Some folks I've seen in their apps have just kind of included them in there during the assignments. We've played with navigation controllers or navigation stuff. And then in terms of views, well, there's this last one called a window, which basically, if you haven't noticed this yet, on the iPhone, you don't really have multiple windows when you're interacting with your application. You have multiple views. And when you're on OS 10, it actually turns out that a window is sort of its own separate thing. But here on the iPhone, a window happens to actually be a UI web view as well. I'm sorry, a UI view. Basically, things are just set up so that you only have one window. And I think I saw some folks that came to me. There were a few little. It was just accidental. Oops, I mislabeled something. But suddenly, instead of dragging a view into their view, they put in another window, so things weren't quite working right. And so we'll look through basically just a little bit of the hierarchy of how the classes are set up. So we see that the UI view inherits from this UI responder and NS object, which we've sort of dealt with. So UI responder takes care of some of the interface, like the actual interaction stuff. And then, basically, I think you could almost think of, well, you can actually instantiate UI views, but usually there's something else that inherits off of it that actually takes care of the display. So we've got window, which we talked about. So we see it's just another type of UI view. We have labels, pickers, which they sort of look like those jackpot things like in Vegas. Those you pull the slot thing. It's basically Apple's way of taking care of drop-down menus. So on the iPhone, you don't really have drop-down menus. Instead, you have this thing, and we'll look at the picker in a second, but just makes it easy to choose things. A progress view, activity indicator. Pretty obvious from the name as far as what some of these do. Let's see, we've Well, recently we dealt with table views, and if we look, so all of these inherit off of Uiview. I just cut the image a little bit to get things a little more compact. But we dealt with table views this time around, and it turns out that table views happen to inherit off of scroll views. So they're able to kind of move around, and as far as table views are concerned, they're limited to this vertical motion. Question?
So these are on UI?
Yes.
Just like that line and then just step off the UI control?
Yes, so all of these, you just pretend that this line underneath UI activity indicator keeps dropping, and so on the left side, and then on the right side there's again that little bit. And so those are pretty much what we have access to for free, right? So someone at Apple, lots of folks at Apple or wherever over the years sat down and implemented all these, and now we can just kind of drag and drop and use them in Interface Builder or outside of Interface Builder, as we'll see. So one of the things that's important to understand about views is sort of the coordinate system and how that sort of works. And so in this case, I've taken this image from the documentation, and we see that up in the upper left corner there's this 0, 0, and then it increases in X across and increases in Y down. So this is sort of flipped in terms of what most people are used to. Usually we're used to Y going up. And this was just a convention chosen that supposedly it makes things easier to place and understand the positioning of objects. And so that big screen in the back with the little tiny squares, the grid, will say that that's a UI window. And now this other little this rectangle that's a little bit, I don't know if it's how transparent it looks to you guys there, but a little transparent with a little border. The first thing of note is this frame origin. So every view has some sort of origin, has some location in space. And, well, let me step back. Every single view has a frame, and a frame consists of an origin and a size, where the size takes care of the width and the height. So for the example that's listed here, the origin is at location 2, 2. And, so this is with respect to the UI window. So, and then if we look, right, the frame has this size, and it's a width, and it's a width of 4. Yes?
So you can have cascading origins.
Right, so the question or the comment was, so we can have cascading origins. So I don't know if I would just, that's one way to sort of think about it, I guess, but definitely what we'll eventually see in the next few slides is that basically every view has its own coordinate system, and then it also has this frame origin and this center value that happens to be in the coordinate system of its parent. So again, in this case, like right now we haven't done anything fancy, just we've got these red axes, and it just so happens that what we're calling the frame origin for this this white rectangle, its origin happens to be 2, 2. And then it has a center in that red coordinate system of 4, 5. So we have this notion of a frame, but we also have the notion of bounds. And bounds is basically that gives us the information, or basically the coordinate system within this UI view. So this rectangle here, we say it has a bounds origin at 0, 0, and it has bounds with size width of 4 and size height of 5. So in this case, the frame that we looked at previously had a width of 4. Okay, so that's actually a mistake. I changed something at the kind of end there. The power of that. Okay, so right? 1, 2, 3, 4, 5, 6. Okay. So the frame, the width and height of the frame in this case is the same as the bounds width and height. So those match up. The only thing that's different is that the frame origin is 2, 2, and then this bounds origin is 0. So basically, if when we drew the view inside the window, we positioned it at some location. So the drawing of this rectangle was relative to the window, its parent. So if so now if we wanted to actually draw something inside of this rectangle, inside of this view, it all happens relative to this bounds origin. So if if I wanted to draw a little triangle in there, what I could do is I could say, draw a triangle at point, let's see, so 0, 1, 2, so 2 in x, and 1 down in y. So that would give us the top of the triangle. So basically you would give the coordinates of the triangle with respect to this bounds origin. And yes?
Can you have bounds that are
So the question is, can you have right? So can you have coordinates outside of the bounds? And the answer, I believe, is yes. I think what you can do. So, given the bounds, can I draw outside of them? So the answer is yes, you can. And I think there's a setting that you could turn clipping on and off. So you could say, well, if anything happens to be outside of my bounds, then don't actually display it. So what's interesting is, so by default, this setup that I've shown here where the bounds origin is at a certain place, you can actually change the origin. So if for whatever reason you're drawing something and it's just easier to have that origin at a different location, you can set it and maybe putting it in the very center of the view makes it easier for you to do something in polar coordinates or something. I don't know if you wanted to draw some weird, I don't know, whatever some of those things were called from back in the day. Okay, so basically that was sort of, we'll come back and look through this again in a second. What I wanted to do, and I kind of skipped it, was I wanted to look at a bunch of these elements and to show you a place where you can look in some of the samples. And so, as usual, so I've had some folks come up to me, ask me some things that, basically, let's say I want to make sure everyone knows where the documentation is, because the documentation is really good. It's just there's a lot of it. So again, from Xcode help, we get our developer documentation, and sort of, if you go to home for the iPhone OS 3, so you'll have probably a few less things in there, but this will be the one you'll go to. The first thing that you have this list, this big list of documents. If you type, sample code, you get 76 samples that are at least documented here. So for a lot of folks that start heading down certain paths where we just haven't happened to lecture on the material yet. So if you're going to do audio stuff, for example, well, the first few samples that come up are audio related. And there are a bunch that are related to views. Well, now it's going to bring up a bunch of different documentation and stuff, but reference documentation. There are also guides that tell you how to, bless you. So if view controllers are still weird and you haven't found this yet, there's this view controller programming guide. And in terms of views, we see, alternate views, heads-up UI, scroll view suite, scrolling, table view. There are a lot of little things here that that will be useful. The one that I want to show you right now just happens to be called catalog. And usually what will happen, you'll click on it, it'll give you some description about it. In this case, this one is something that exhibits many views and controls in the UI kit framework, along with various properties and styles. So if you're wondering how does some particular UI kit or Uiview work, you can just fire this up and open the project in Xcode, and it'll ask you to save it somewhere. And I've already got it on the desktop, so I won't. And so let's build it and run it and check it out real quick. Let's see what we've got. Something bad happened. Well, that was slow for some reason. Okay. So basically, you get this catalog of all the different things. So, so buttons. Oh, you want a little fancier button? Here's sort of how to take care of it, and what happens when you press it. You want to have, an image or something special on there. This is a good place to take a look and see how some of this stuff is done. These little info buttons that you kind of see around, and these contacts. My machine's freaking out. Weird. So, I mentioned pickers. Right, sort of like drop-down menus, except we don't have the real estate on the iPhone, so they did this sort of Tumblr-looking thing. And you'll see this in a number of different applications, usually anywhere where you have to set time or something, like a timer. You'll see this guy in there. And so, they get fancy. You can sort of choose how to do various things with them. And you can even make your own custom ones where you've got like little tiny images there on the side. So again, all this is there. And let's see, we haven't really messed much with alerts, for example. So, there's this action sheet, this kind that sort of slides up from the bottom. And there's this kind that pops up, and they're very easy to use. So let's take a look. So if we look closely at any one of these samples, you'll see alerts view controller.m, alert simple action. So we can jump over there. Alerts view. So Command Shift D, alerts view controller.m, and it looks like I need to boost this thing again. Fonts and colors. Okay, and it was said that its alert simple action was the method. So we can get a quick look to see, for example, how an alert would be set up. In this case, so you push this action, and pretty much some stuff we've seen, right? The class, alloc. In this case, we call whatever the initializer happens to be. And this one, in it with title, message, and we have to pass in a delegate, some sort of cancel button title, and other buttons. So if you wanted to have a few other buttons, I guess you could put them in there. And so this is a good place to look to get a feel for how some of the various views work. And so I think we'll leave that one for now. And so we're gonna take a look at views at another sample with views, and just kind of walk through and see how it is that we can draw the view using some custom stuff, and how to click in certain places and make the view sort of follow where you click. And again, this is one of the samples that Apple provides, and we'll go through it, and this is one of the places we'll see how to do things more in code and less through Interface Builder. So the sample of interest is I believe it's called Move Me. So it's under this user experience topic. So I already have it here on the desktop. Let me make this stop. I don't know why it's... Okay. So let's run this real quick and see how it works, and then we'll dissect it. We'll walk through and see sort of how is this view built, and how do we do the things that it does. So nothing too fancy. This thing comes up on a gray background, and it says welcome. So if I click, okay, something's wrong with my machine here. Give me a second, please. So out of memory, you go away. OmniGraffle. You go away. Later. All right, so hopefully things are okay. Everything's really sluggish for some reason, so I just want to clean up. So for those of you with computers, if you haven't grabbed it yet, just grab the Move Me app from the documentation there, and we'll walk through it shortly. Okay, so hopefully that took care of whatever weirdness was going on. Okay. Okay. So we can drag and move this guy somewhere, and it bounces back. So that seems like it was a user error part of that. There was a different one where you click somewhere, it would kind of follow to the mouse. But actually, so with this one, so you can click, drag, and you see how when we click on it, it sort of scales up a little bit and kind of does this little animation, bounces back. We can also, if we double click outside of it, it'll start changing these strings through a few different languages. So this is one of the nice things about using NS strings. They happen to be localized, or they're in a different format. They're not just standard ASCII, and so you can display in a lot of different languages. So okay. And so that's sort of the gist of what this thing does. So let's take a look at how it's structured. So if we look, we sort of see the usual stuff. We see our classes and our app delegate, which has sort of the usual stuff in there, usual characters, the window, and a view controller. And I think what we'll see here is, we'll see how to actually set up the view controller in code instead of actually making the connection inside Interface Builder. We then have these two other, we have these views, this Move Me view and this placard view. So if we look at the Move Me view, it's just something that inherits off a Uiview. and it happens to contain this placard view. And so let's take a quick look at the placard view just to see sort of what's inside of it. Basically, it has a UI image, so pretty descriptive. Chances are that UI image contains an image. So we'll see how to kind of, how to bring an image in off disk and display it. And then we've got some strings, or the current string and font and size of the text, and then a bunch of other strings, and then these indices. And so let's start with the application did finish launching. So that's always a good, you're trying to walk through some code. This is always a good place to start, just because this is sort of your first hook into the application, so you can see what's going on. So the other thing that's nice with some of this code is it's been commented, because it's meant to be sample code where it'll help you out. So in this case, we see that the first thing that's happening is we need to set up the usual model view controller stuff. So we need to have some sort of controller. In this case, we're creating a Uiview controller, and much like other stuff we've allocated, in text, we take our class and call this class method alloc on it, and in this case, Uiview controller has this initializer, which is init with nib name, move me view, and there's this bundle, which basically the bundle basically is just information about your application and sort of where things are. So, like, one of the nice things that that I've always liked about Apple, or at least OS X, and the first time I used it, it really messed me up, was that I wanted to uninstall something. And so, I had this old Windows mindset of, I got to go somewhere special, and I have to tell it to uninstall to make sure everything gets removed cleanly and all that kind of stuff. Well, on OS X and on the iPhone, things are put into these nice bundles. So when it's time to get rid of your application, you just take it and drag it and throw it to the trash. And there might be like little preference files that are put somewhere, but it's not like Windows registry and weird stuff that you have to be super careful about how you remove things. Anyways, this NS bundle, main bundle, basically just says, hey, give me the stuff I need for the resources for this application. So, okay, so we're allocating this controller. Well, when we create a controller, we need, if you remember when we dealt with an interface builder, our controller had a view, and that view was always connected to something. So in this case, what we're telling, we're building on the command line, or allocating this thing in the code here. We need to tell it, well, what's my view going to be? So it's this move me view, and we can go ahead and look at the nib file for it and see what's in there. And if we look, there really isn't much. There's basically, our usual files owner stuff and this first responder thing, and then there's this move me view, which, if we look, usual stuff, same, the type of stuff you did for this last assignment, right? We set the class for this view, this view pretty much has nothing to it except a gray background, which we saw that's kind of the background things we're floating around on. So we create our view controller, and because we've set up our own our view controller. Notice this time around it's not an IB outlet, so we're not actually doing any connections inside Interface Builder. So we just allocate, or assign that view controller to ourselves. We release this one because we just allocated it, and we now ask our view controller for this view, which happens to be this move me view that we set up. And same as what we saw before when we were using Interface Builder, we just add the sub view and kind of go on our merry way. So, yes.
Can you just allocate it and
What's the view control? Why they have that temporary?
So basically, why bother with this temporary pointer, and why not just assign it directly here? So basically, if you wanted to do that, just a few things change in terms of memory allocation stuff. So you could say, well, basically you could do it all in one line. You could say view controller equals this stuff, and basically then and then you get rid of all of this. So I assert that this is equivalent to the stuff I've commented out, and here's why. So basically we have our view controller, and you should be using self so that you make use of these properties, which in this case happens to be retain and non-atomic. But what we've done instead is said, well, we have a pointer. I've just allocated some stuff, so let me assign what I've allocated to this pointer. And then you're fine, right? Because at some point later on in dealloc, you're going to release it. So, we've allocated something. Our retain count is 1. Eventually, in the future, we release it. So, if we do this self.viewController route, well, we have our retain count of 1 from alloc, but our property is retain. So we're going to send a retain message to this thing again, so now suddenly our retain count is up to 2. So, part of why they're doing this is just to be a little more verbose in terms of how things work, and then, it's just important to know, if you go one route versus the other, you just need to be aware of sort of the memory allocation implications. So this first way here, this is sort of the lazier way, because I didn't have to type self, and you got around the property stuff, which could be bad actually, depending on how important these settings are here for you. So I would say, just know how it works in terms of the memory allocation stuff, and if we look at how it was done here, we see, right, we've allocated it. So our retain count is 1. We've assigned it through the property, so our retain count goes to 2. So now we go ahead and release and drop our retain count back to 1. So at some point in the future, our view controller gets released, and the retain count drops to 0, and memory's freed, and we're all happy. You good? Okay. So let's see. So we've just created a view controller, and we've given it a view, and in this case it was move me view. So let me save this, and hopefully I didn't mess anything up in that process. But yes?
Is it even slower if we do this in code instead of interface builder?
Slower performance-wise, or slower?
Performance-wise. Okay,
so will this be slower if we do it in code versus in interface builder? I don't think it really would be. If it is, it'd probably be negligible. So I don't know if you're getting at the fact that, well, interface builder has archived the object, and so maybe it's easier. So it's serialized it in this whatever way it does, and then maybe it's faster to unserialize it and bring it into memory than it is to allocate this. I think sort of the same sort of process happens, right? You're still going to need to allocate memory for it, and then you bring this thing in and sort of unarchive it into memory. So it feels like sort of the same thing going on. Slightly different, of course, because you have this unarchiving stuff that needs to go on, but I don't think I would worry. So when it comes to performance, the usual thing for me, and I learned this, and I'll tell you a little story here real quick. I wrote an application for the Palm 5 something or other. Remember that silverish, it had the thin silver whatever, it was like all fancy back in the day. I got that for my birthday in 2000 or something. And basically I had an application similar to that game that I showed you guys, where I had this board of letters and I needed to solve that board. And much like the iPhone now, and sort of what the Palm Pilot established, was that when a user picks up the Palm Pilot, iPhone now, you hit an application, and that application launches, and that user needs to be doing something quickly, and they need to be in and out in very short amount of time. Granted, with games and things, it's a little different, but the idea is you bring it up, spend very little time. Oh, let me input my, let me calculate the tip that I need to, whatever, to pay for dinner or something. Okay, boom, I'm done. Oh, let me expense this, let me do whatever, and you're in and out quickly. So with the game I was writing, on launch, it took 12 seconds. It took it 12 seconds to solve this board. Now granted, the Palm Pilot, that thing was running 16 megahertz with 2 megabytes of RAM. So to me, I view that as an embedded device, which probably there are people older than me who don't view that as an embedded device because they had even less memory on whatever they were using. And someday it'll be the same for you guys. And so 12 seconds. And I looked through that thing, and my friend and I sat down, and we did all these crazy optimizations, caching stuff here and this and that. And we got it down to 10 seconds. Like, we did a ridiculous amount of stuff. It made the code super ugly and disgusting, and we went from 12 seconds to 10 seconds, which, that's a nice improvement, but it still didn't meet the requirements of, the requirements that, at least from a user perspective, what I expect when I use this sort of device. I pick it up, I intend to be using it quickly. So it bugs me to no end now, like when games and things, they start up, it takes them forever just to get going. So basically what ended up happening was, the Palm Pilot doesn't have threads. So essentially what I needed was some sort of threading type behavior where, it's basically just in this game loop where, the user starts and, give the Palm Pilot a split second to solve a little bit of the board, let the user continue to do stuff. And, it actually turns out it took most people, it took them more than 10 seconds to actually find the first word in this puzzle. So basically the lesson is, start optimizing wherever instruments, which we will look at more later, tells you to. So no premature optimization. I think it was Donald Knuth that says that. So long story short, that's kind of, don't worry about that for this. But it was a good question because it's, wondering how things work. So back to this. So now we see that we've created our controller. We've given it, we've initialized it with this move me view. We looked at the view nib, and there's pretty much nothing in there except a gray background. So let's go ahead and actually look at the code for the move me Uiview. So we saw earlier in my, when we first kind of went through that it basically has a placard view, and it's set it up as a property of this non-atomic retain stuff. And we've got a few things. We'll see how much we look at these animate and animate. Well, we'll definitely be looking at them, but and sort of some setup stuff for it. So if we jump to the implementation file and go through all of the stuff here. Okay, so we synthesize our setters and getters, and we now, so one of the functions or one of the initializers we see is init with coder. So again, if we just look at the comment that was made up here for us so nicely by probably an intern at Apple that spent their summer doing this kind of stuff. So the idea is if the view is stored in some sort of nib, when it's unarchived using this, this deserialization or this unarchiving mechanism that we have available to us, what you want to do is, it'll call this method, init with coder. So again, our usual thing. So that one has no documentation. That's interesting. So basically, this is the initializer that would get called when we bring in this view from the nib file. So given the way that we initialized it, that nib is going to come in from moveme.nib, and this function will get called. And what we're doing here is, we're giving our parent class a chance to sort of do whatever initialization it needs to do. And in this case, our parent is a Uiview. And the next thing we're doing is we're doing this setup placard view. So I say, let's make sure I'm not just like pulling your leg in terms of how things are working, and let's step through and see. So it looks like I'm oh, okay. I was like, wait, that already came up and it didn't do anything. So, okay, so I set up a breakpoint in the application did finish launching. And so remember, when we have, just based on sort of the way that Apple does things, it's this lazy mentality where, load things when they need to be loaded, allocate things when they need to be allocated, and that's because, we have a limited amount of memory. So what should happen here is, well, what happened when we were set up with Interface Builder is, if we tried to access a view and it was nil, it would go through like all this sorts of stuff and allocate things and bring things into memory and do all the connections and things. So in this case, we have our view controller and we just want to access the view. So if I step over, so what this is telling me is at this moment, when I grabbed the view, this was when it actually did the allocation, because so view had, even though we told it to initialize that controller and we gave it that move me nib name, it just sort of kept track of it, probably kept track of the file name or whatever. And right now when we asked for the view was probably nil, so it said, okay, now they're really serious. They really want to display this thing. So let's go ahead and grab it and unarchive it, and we'll call this method init with coder. So all right, we'll let our parent do whatever they need to do, and let's step into this setup placard view and see some of the magic that goes on in here. So, yes?
So there's also another method init with
Yes.
bundle. So if you implemented like your setup with placard view, setup placard view in there, then it'll be called right away. As soon as you have that command init with init in the previous file.
So in the previous file,
So right there.
okay, so the question is what again?
So would that be called right away, or would it also be lazy like init with coder, which is only called when we set the view?
I think it would do, it would do the same thing, I believe. So the question is, so we're doing init with nib name, and well, so we wouldn't be doing init with nib name. It would be some other init. So let's see what other initializers we have in here. So again, the Apple or the command key, double click. So we've got init with nib name. We have load view, view did load, view unload, is view loaded. So I guess that is our only. Let's see, init. So is that our only initializer on a Uiview? I guess it is. Okay, so
This is a Uiview controller.
right. So which one are you asking about then, or what?
So you can also override init with nibname.
Okay.
And so I was just wondering if you knew if that would also be called when you actually needed it, or would that be called right away? And then what would be the difference between init with coder and init with nibname?
So I think, so pretty much so when you call init with nibname, it's definitely getting called, right? So init with nibname went off and did something. So if you override that, it's going to go off and do something. The thing is, I'm not sure about the exact behavior. I think probably the best thing to do would be to actually go ahead and do it and then walk through and see kind of how it behaves. Because I'm not 100% sure of how it would go. So okay, so I'm going to punt on that for now, and if you find out, let me know, and we'll see. Okay, so we were headed into the placard view, move me view setup. Okay, so we just did the init with coder. Now we're doing whatever setup we need to do for ourselves. And basically, the first thing we're doing, allocating a placard view and doing initialization, and I guess we'll just step inside and see what that does. So here we have our placard view, and it's time to initialize it. So in this case, we have another, it's another Uiview, and it's got a bunch of stuff, these images and display strings and whatnot. So the first thing we see going on is that we're asking Uimage, so some other view, to basically create an Uimage and use the name placard.png. So if we look in our resources, we'll see that there's a placard PNG, and this is basically what's there. So it's just this rounded rectangle with a little gradient thing. And so the fact that this image is inside the application and in the resources, when it's all bundled together and created into an application, that's all those resources also get copied along. So Uimage will sort of look through and try to find this file. And in this case, we're using image named, so we're not doing an alloc init type of thing. We're calling this class method to actually just get a Uimage. And what should happen at some point, if anyone cares about this image, is it should actually be retained, which I think there's actually a bug in here, but we'll see. Anyway. Okay, so we talked about how our views have these frames, and we were saying that the frame has some sort of an origin, and it has some sort of a width and a height. So it turns out that the frame is this object called Rect, and it's a structure. So, most of the time we're using things as pointers, but this is where we have Objective-C, and it's this mix of C and Objective-C stuff, and occasionally C++, depending how you do things. So if we look at this Rect, so CG is core graphics, and we look inside there, and we have two things. There's like a typedef and a struct. Let's look inside the struct, and we see, it's got an origin and a size, and the origin is a CG point, so I expect to see a structure CG point that has float X and a Y. So those are same thing going on, and they're using CG floats, but at the end of the day, it's typedef to a float. So we've got our point, and as long as we're here, we might as well look at CG size as well. So it's this width and height. So we have this structure of some structures that is this Rect, and that defines our frame. So remember, the origin is some point with respect to a parent view. So for right now, we're just, we're making, we're essentially creating a frame which for now is pretty much, it's placing that image at coordinate 0, 0 in terms of, well, not quite yet, but that's where it would be in, in this image here, right? So it's almost like, well, this guy would be up there in terms of that frame itself. And so CG Rect make is just some C function, again, from core graphics, that basically takes this information in, and we look, and it seems like the Uimage has some information for us. Well, a Uimage also has has a size associated with it and a width, which has a width and a height, and so we make that frame, and now what we do is, well, we initialize ourselves with this frame. So this is sort of calling our we're just initializing ourselves with the frame to actually say, well, we've created the frame, well, let's now go ahead and actually initialize ourselves with it. And let's see, we have a few other things. So we're saying that we're opaque, and no, that's not true. So this is just a property on the view, is the opacity. So this is the point where I was thinking that something is off, because, we used a Uimage, image named, and unless the documentation says otherwise, I expect that, this image, what we really should have is self, right? So our placard image has this property, non-atomic retain. If we, so UI image is probably some auto-released object, let's see, maybe the documentation says otherwise, that no, it's not really, it behaves differently than what we're used to. All right, so return the image associated with this file name. Discussion, let's see. Return value. So the image object specified or nil if it couldn't find it. This discussion here. So this is usually where you would see something different or more interesting in terms of what's going on. So this method looks in the system, caches for an image object with the specified name, and returns that object if it exists. If a matching object is not already there, then it loads it from the specified file, caches it, and returns the resulting object. So in my mind, from that description, given what we know about the memory allocation and those rules about NARC, new alloc, retain, and copy, I would expect this UI image to be released, to be freed at some point. So it could be that because of the caching behavior, we're not really seeing a problem. But who knows, if we went on and on and on, eventually maybe this image would get kicked out of memory, and eventually we try to access it and we'd have issues. So again, I think this is a bug in the Apple stuff. I would expect this to be self.placard image. I could be wrong. Maybe someone at Apple who sees this can call me at some point and tell me that I don't know what I'm talking about. So does that make sense? Do you see why I'm thinking this? Yes, Chris?
I'm still not clear on the difference between self-dot and just leaving it out if it's a class-level variable.
Okay, so I happen to know that, Chris, you come from C++ land, so that's why it's awkward. So the question is, what's the difference between self-dot versus just, saying placard image? So for those of us that come from C++, and for those of you with more Java experience, you can correct me if I'm wrong, but when you access an instance variable or even any of the any of the member functions of that class, what happens at compile time, and basically this, when you're accessing member variables and member functions, there's this implicit this in front of whatever you're doing. So again, in C++, we want to say we're accessing placard image, saying this.placard image and saying placard image would be the same thing. In Objective-C, that is not the case. So when you say placard image, what you're saying is placard image. It's just, in the sense that, you're just accessing this variable here, which, because what we've done is we've set up properties, we have setters and getters, we would expect those setters and getters to get called. So I guess the best way to explain this is when you just refer to the variable name, you have access to that variable name, but there is no implicit self dot placed in front of there for you. You have to explicitly state, what, I want self dot placard image, because this is the mechanism by which Objective-C will actually call your, in this case, your setter. Right, so we've set up our placard image, and we've done this non-atomic thing, which means we don't care about threads, or threads aren't really going to be accessing this. And what we want is this retain setter semantics. So to actually get that, you have to say self dot. So that's why I was kind of saying, if you just say placard image equals, it's basically just saying we'll take one pointer and assign it to another one. But you're not getting the retain that we would expect, which means at some point in the future, which again, looking at this the way it's set up, UI image named, inside image named, the first thing it's going to do is say UI image alloc, and then who knows what other stuff, and at the end of that is auto release, which means at some point at the end of this run loop, the image is gone. Again, I think because of the way the UI image works internally in terms of it caching things, it just sort of happens to work out. So is that clear for folks, the difference between, in order to actually get to your setters and getters, you have to say self dot. Okay. So moving on. Okay, well, I thought we would finish early today. So load the display setting, the display string. So again, we have some strings somewhere, and they're brought in, and if somewhere being over here in our resources. So those are being. So we get a path to them, and then we bring them in. So NS string happens to have this string with contents of file, so we give it the path that we just grabbed, and we give it an encoding, which this is something to look at. So there are a bunch of different types of encodings, UTF-8, UTF-16. So all of this happens, has to do with localization and being able to, not all characters can fit in our 8 bits, in our 8-bit ASCII that we're used to in the US. So, we have a few more properties that get set. This self-display string. So here they did it, right? They say string components separated by string. Well, same thing. The string that, well, actually, this is a little different. Never mind. But, we're retaining whatever it is that we're getting because of the self. And again, it's got to retain. And let's see what's in here. We'll probably just skip over what's going on. Basically, they're just playing with some strings. So I'm going to ignore them and step back out. Well, they're playing with some strings and setting up some fonts. So maybe this is useful to see. All right, let's set the font to be this size 24. And again, just sort of set up some other things. Now, the other thing, what's happening here at the very end, is this set needs display, and we haven't talked about this one yet. Okay, so it's a good point to, I guess, a good time to bring this up. So right now we've just initialized everything. Now, when it's time to actually display something, there's this method called drawRect that ends up getting called. So in this case, what we're saying is, okay, well, we have our placard image, and we're telling it to draw at some point. And in this case, they're saying draw it at 0, 0. And, we're getting some more information, some X, Y coordinates, and, some sort of font information. And I guess I should slow down for this a bit. So this function is very important. So basically, drawRect, this is what draws the view. So we'll come back to that in a second, and I'll say what drew me to go up there. So let's say we set up the rest of the things that we need to set up. We've set up our font. We set up this text size, and the last thing we say is self set needs display. And what happens? This is the way of sort of telling the system, hey, this view needs drawRect to be called on it at some point in the future when you see fit. So in general, when you say you manipulate something that needs to get displayed, you wouldn't call drawRect yourself directly. You would say, hey, set needs display, and at some point, again, when the system is ready to, after it's batched, whatever it's batched together and tried to do whatever it can do as efficiently as it possibly can, it will then call drawRect for you, which I will put a breakpoint in there real quick so we can walk through there as well. So I will continue, and I expect drawRect to hopefully get called, and it did. So we set needs display, drawRect gets called. So now we're trying to actually display this view. So this placard image, so it turns out that I don't know if it's the view itself or if it's probably, well, it's the image, has this draw at point. So we're telling the placard view to draw itself at 0, 0. And so find point at which to draw string so it will be in center of the view. So, all right, in this case, we're looking at our bounds, which, let's see if this will give us a bit. So ideally that would show us some stuff, but it's not. So we could see the width and height that we've gotten. So basically what it's doing, it's looking at our bounds, which if you remember, at least from this example that I was showing here, I had set up the frame and the origin to have the same width and height. The only difference was that the frame origin was at a certain location, whereas the bounds origin was 0, 0. So in this case, we're looking at, basically, let's look at our width and our height, and well, let's look at the width of our bounds. Let's look at the width of our text, subtract them, or divide those by 2 and subtract them. So that's trying to get some x location within the view, and then we're going to do the same thing for the y. And I don't know if they're doing anything with that yet, but so where'd font size? So font size, I think was something we computed or set earlier, and basically we're just asking system, give me a font of this size. And what we can do, because we're in this draw method here, what it looks like what we're getting ready to do is actually draw the string. So we've set up a bunch of things that we need to do that, and there's this class UI color where we can ask it for various colors. In this case, they asked for black. And what happens is when we're drawing, I guess let me step back for just a second. So every time we draw a view has what's referred to as a context. And so the simplest way to think of a context is basically a set of parameters that define the properties of the thing that you're going to draw into. So we've set the font for this context, and right now what we're going to do is we're going to set the color. And so we've set the color, we've set the font, we've set the font size, and so let's see, we'll continue forward here. They're making this other point, so they're offsetting the y by half for some reason. And so right now we see again this draw at point. This time it's it's a little more involved because they're different things. So we're taking our current string, and which happens to be, well, it's not showing what it is for some reason, but we have our current string, and we're going to draw it at some point, which is the point we just set up. And again, just a bunch of things. So for some width with some particular font, set up a few parameters. Line break mode, which you can look at all of these and see, well, what is line break middle truncation? So in this particular case, if the string is too long, what it'll do is it'll show you the first few characters, it'll show you ... and then it'll show you more of the string. So we're telling it to draw at that location. Now we're changing the color to white, and again, now we have some other point which was just the XY we computed, and we're going to draw the string again. So what it seems like is they're trying to draw the string twice, once in black and slightly offset. So they're trying to make it look like it has a shadow probably. So it's drawn once in black, offset by this in Y by 0.5. So we should see a small little shadow downward. And then they change the color to white, and this time around they draw it half a unit up, and with all the same settings again. And so we continue on. So now basically, and if we look really closely, you sort of see that there's like a little bit of black underneath the W. It's easiest to see under the W, I think. I don't know. Yeah. So it drew it drew up our stuff here. There's what I'm not sure of is where it drew the white border around the placard. So right now we're in the placard view. We did some stuff. So move me view. Let me see. I don't know if this one has its own different draw. It does not. I'm sorry?
Part of the image.
Was it part of the image? Okay, I hadn't noticed. Oh, yeah, I guess there it is. If we look, there's a little bit of white there somewhere. I don't know. Okay, so good. That was taken care of in the image. So, okay, so that's, I think we'll definitely follow up with more in terms of some details in terms of context and all this kind of stuff, but yeah, this makes the next assignment harder, I guess. Not harder, but we'll see. We'll see what I send you guys. I might just do a little more hand-holding in terms of the directions, in terms of anything I feel like I didn't cover that I need you to do for the next assignment. But okay, so important things about what we just saw. So we saw how to initialize a view when doing it outside of Interface Builder. So we have some we had some resources, in this case an image, and so we had this UI image view for our placard, and we had a few other things associated with it, some strings and values for sizes and whatnot, and we set things up, and eventually, because of all these changes, it was time to want to make sure that we get displayed. So we called this set needs display, and so we know now whenever something important happens, or for whatever reason the system says, well, something needs to be drawn, say in response to your set needs display, all views have this method called drawRect, and inside there you can do things like exactly what we were doing, take an image and draw it at some location. There are other things we can do which we don't have time to look at today, but there's something called Quartz Graphics, it's Quartz, and it's basically a 2D graphics engine that that's available on OS X and on the iPhone. And generally what you use it for is drawing user interface elements, which normally, and I've had to do this for some folks, where for whatever reason things need to be super customizable, and at runtime I needed to use Quartz to draw rounded rectangles of some particular color, or I needed to draw little triangles of specific colors and whatnot. It was just easier to use this 2D engine to do it. So Quartz, you'll hear about a few different graphics things on the iPhone and for OS X as well. So we have Quartz, which is this 2D engine. You also have OpenGL, which OpenGL and Quartz are similar in that they're fairly low level, with OpenGL being even lower level. I wouldn't be surprised if Quartz is actually implemented on top of OpenGL, but who knows, depends on kind of when these things came to be. But so I think, I don't know, we'll see. There'll be probably 2 lectures on OpenGL. I don't know if we'll really get into Quartz. The main thing is you're going to use OpenGL. You could use it to do user interface stuff, but usually if you don't know OpenGL, it seems like folks tend to use Quartz, and you'll end up using OpenGL if you're going to say do a game or something where performance is super important. You probably could do that stuff with Quartz. I don't know if I would. It just, from what I've seen of it, it seems more cumbersome, and maybe it's just because I know OpenGL more than Quartz. I don't know. But Quartz is something, or OpenGL is something you would use if you're going to do 3D stuff or super high performance stuff. And again, there are a few folks in here who've mentioned that they're thinking about writing some games. And I'll mention the engine again. It's called Cocos 2D. It's an Objective-C 2D game engine, which is built on top of OpenGL. So you can do a lot of stuff without really knowing how OpenGL works down under in the trenches. if performance becomes an issue, then it's really important to know how the OpenGL stuff works. So hopefully, yeah, we'll definitely be seeing OpenGL at some point before the quarter ends. For folks that are doing their applications using OpenGL, you're going to have to sort of probably trek forward ahead of us. And again, that's just how it's going to be, unfortunately, because there's too much stuff to cover. So what we didn't get to discuss, and we will look at probably next time as we kind of continue on with this, is actually the interaction of, what happens, like how do I actually click on something, and oops, is that in here? How do we actually respond to the user interface, well, to the clicks? And okay, so I'll just say this real quick, where basically you have a set of these methods that you can override for all of your views, and it's sort of like the names are fairly self-explanatory. Touches began, touches moved, touches ended, touches canceled. I think you can guess what happens. So basically next time what we'll do is we'll look at how these are set up, and maybe we'll look at some more graphic stuff, and yeah, we'll go from there. So I don't know, we'll see what I'll do about the third assignment, just because there's a lot more in here that we need to discuss that maybe I'll just make you do it on your own. We'll see. I'll talk to Ken. So, all right, if there are no other questions, yeah, I will see you next time. We'll try to do some grading right now. I think there's a phone meeting I should be on right now, so I got to call in. And please wait around for me, and we'll figure it out. Okay? Thank you.